Hello students, today we are going to study equations of motion. In last video, we learned displacement that is equal to final position minus initial position. If x2 is the final position and x1 is the initial position, then displacement x is equal to x2 minus x1. Then velocity, which is equal to displacement by time taken, or it is the rate of change of displacement. Acceleration, it is the change in velocity by time taken, or it is rate of change of velocity. Then initial velocity, final velocity, and time taken t. So this first equation of motion is interrelated with displacement, velocity, which is initial velocity, final velocity, acceleration, and time taken t. So we see that all these terms are interrelated, but what is the nature of relationship between these terms and how exactly they are interrelated? So in order to solve this problem, we derive equation of motion, and for deriving first equation of motion, let us ignore displacement. So we know that acceleration is equal to change in velocity by time taken, and change in velocity is nothing but final velocity minus initial velocity. So we get A is equal to final velocity minus initial velocity by time taken, and final velocity is denoted by V, initial velocity is u, and time taken is t. Therefore we get acceleration A is equal to v minus u by t. Here we have to consider that acceleration to be constant. So by rearranging the equation, we get A into t is equal to v minus u. So v is equal to u plus at is a first equation of motion. So in words we can write v means final velocity is equal to initial velocity plus change in velocity, and as A is equal to change in velocity by time, therefore change in velocity is equal to A into t, or acceleration into time. So we can substitute this change in velocity. We get final velocity is equal to initial velocity plus acceleration into time. So if we consider an object which started with velocity 10 meter per second and it is moving with constant acceleration of 1 meter per second square for 5 seconds, then its final velocity is, so the object started with velocity 10 meter per second, its acceleration is 1 meter per second square, means 1 meter per second. So its velocity changing by 1 meter per second every second. So in 5 seconds, velocity change by 5 meter per second. That means acceleration into time we get 5 meter per second. So its final velocity is equal to initial velocity, that is 10 meter per second, plus change in velocity is 5 meter per second, which is equal to 15 meter per second. Means when acceleration is constant, we can multiply it with time, because each time period the acceleration is same to get change in velocity added to initial velocity to get the final velocity. So here note that we cannot do it if acceleration is not constant, because in this case time period, for each time period we have different acceleration, and so the first equation of motion relates acceleration, final velocity, initial velocity and time taken. So given any three of these terms, we can find the fourth one. The equations of motion are valid only when the motion is in one dimension, means body is moving along a straight line, and the motion is uniformly accelerated, means acceleration, that is A, remains constant. Similarly, we can derive the first equation of motion by graphical method. For that, consider velocity time graph. So time is taken on x-axis, velocity is taken on y-axis. Velocity is measured in meter per second while time is measured in second. O be the origin, and this is a straight line which is graph. C point, this is A point, draw perpendicular from A on time axis, the point is B. Similarly, C on AB, draw perpendicular from C on AB, the point is D. Means CD is parallel to OB and AB is parallel to y-axis, that is velocity axis. U be the velocity, which is initial velocity at a time t is equal to 0, and V is the velocity at a time t second, means V is final velocity. Slope of graph. Here, let us try to find slope. We need 2 points, A and C. So slope of graph is equivalent to acceleration, and which is equal to, for AD upon CD. That means we have to consider triangle ACD, but the value of AD is AB minus BD, where AB is equal to V, that is final velocity, and BD, which is parallel to OC, and OC is equal to U, therefore BD is equal to U. Similarly, CD, which is parallel to OB and which is time t. So we get A is equal to V minus U by t, or A into t is equal to V minus U, or V is equal to U plus AT. This is first equation of motion by graph. We have to solve this problem, that is a car moving with a velocity of 20 meter per second stops in 10 seconds. What is the acceleration? So first write down given parameters. A car moving with a velocity of 20 meter per second means its initial velocity, that is U, is given, stops in 10 seconds. Stops means its final velocity is 0 meter per second, and t is given, that is 10 seconds, and we have to find out acceleration, that is A. So by using first equation of motion, V is equal to U plus AT, putting values of the parameters, so that we get A is equal to minus 2 meter per second square. This negative acceleration means retardation, means velocity of a body decreases. Let us study second equation of motion. We know that displacement x, initial velocity u, final velocity v, acceleration a, and time taken t are interrelated, and in order to determine the nature of relationship between these terms, we derive the equation of motion. So let us derive second equation of motion. For that, we ignore final velocity v and we try to find relation between displacement, initial velocity, acceleration, and time t. The equation of motions are valid only when the motion is in one dimensional, that means body is moving in a straight line, and the motion is uniformly accelerated. That is, acceleration is constant throughout the motion. Now, we have learned that average velocity is equal to initial velocity plus final velocity by 2. This is true when acceleration is constant. Also, u be the initial velocity and v is the final velocity, then average velocity is equal to u plus v by 2. Then average velocity is equal to total displacement by total time. If x is the total displacement and t be the total time, then average velocity is equal to x by t. Equating these two equations, we get u plus v by t 2 is equal to x by t, or x by t is equal to u plus v by 2. From first equation of motion, we get v is equal to u plus at. Putting value of v in this equation, we get x by t is equal to u plus at by 2, or x by t is equal to 2 times u plus at upon 2, or x is equal to ut plus half at square. This is second equation of motion, gives relation between acceleration, initial velocity, displacement and time taken t. Now we derive the second equation of motion by graphical method. So for that we have to again consider initial velocity, displacement, acceleration and time taken t by ignoring final velocity. So first of all, consider velocity time graph for constant acceleration and it is a straight line. So let us consider velocity time graph. This is x-axis on which time is taken. This is y-axis on which velocity is taken. Velocity is measured in meter per second. This is time t. Origin. This is a straight line graph as acceleration is constant. This is C point, A point. Draw perpendicular from A on x-axis. Similarly, draw perpendicular from C on AB. The point is D. U is the initial velocity at a time t is equal to 0. V is final velocity at a time t. So this is a triangle. ACD is a triangle. Then OCDB is a rectangle. So a trapezium is formed, that is OCAB, whose two lines are parallel. AB is parallel to CO. So magnitude of displacement x is equal to area under velocity time graph. That means area of trapezium OCAB. Hence x is equal to area of triangle ACD plus area of rectangle OCDB. So first of all we have to find out area of triangle ACD, which is equal to 1/2 base into height, where base is CD and height is AD for the triangle ACD, plus area of rectangle, that is length into breadth. Length is OB, breadth is BD. Then putting values of CD, AD, OB and BD. First we consider CD, which is parallel to OB and which is equal to T. Similarly, AD is equal to AB minus DB, that means V minus U. Value of OB, which is equal to T. Value of BD, which is parallel to OC, which is equal to U, that is initial velocity. So by putting all these values, we get 1/2 as it is T into V minus U plus UT. Again, from first equation, as V is equal to U plus AT, therefore V minus U is equal to A into T. So we get 1/2 T into AT plus UT. that is x is equal to ut plus 1 half at square. So this is second equation of motion by using graph. Then we have to given a problem and we solve it. The problem is a body under constant acceleration of 8 meter per second square has an initial velocity of 5 meter per second. What will be the displacement of the body at the end of 5 seconds? So first of all, we have to write given parameters. A is equal to 8 meter per second square. That means acceleration is given. Initial velocity u is equal to 5 meter per second and time t is equal to 5 seconds. Then write down equation. X is equal to ut plus 1 half at square. Putting values of given parameters and we get x is equal to 125 meter. Hence displacement of the body x is equal to 125 meter. Third equation of motion. We know that displacement x, initial velocity u, final velocity v, acceleration a and time taken t are interrelated. So let us derive third equation of motion. For that we ignore time taken t and try to find the relation between x, u, v and acceleration. For the equations of motion, the motion is in one dimensional. That means body moves along a straight line and the motion is uniformly accelerated. Means value of acceleration remains constant throughout. We know that average velocity is equal to initial velocity plus final velocity by 2. If u is the initial velocity and v is final velocity, then average velocity is equal to u plus v by 2. Also, average velocity is equal to total displacement by total time. If x is the total displacement and t is total time, then average velocity is equal to x by t. By equating these two equations, we get u plus v by 2 is equal to x by t, or x is equal to u plus v by 2 into t. From the first equation of motion, we get v minus u is equal to at. Therefore, t is equal to v minus u by a. Putting value of t in equation, x is equal to u plus v by 2 into t. Therefore, x is equal to v plus u by 2 into v minus u by a is equal to v square minus u square upon 2a, or v square minus u square is equal to 2ax. Therefore, v square is equal to u square plus 2ax. This is a third equation of motion. Similarly, let us consider equation of motion by graphical method. For that, we have to consider acceleration is to be constant throughout the motion. From velocity time graph, this is a velocity time graph. Time is taken on x-axis in second. Velocity is taken on y-axis, which is measured in meter per second. O be the origin. This is a graph which is a straight line. C and A be the 2 points. Draw perpendicular from A on x-axis. So OCAB trapezium is formed whose two sides are parallel. Means OC and AB are parallel to each other and OB is the distance between them. U is the initial velocity at the time t is equal to 0. V is final velocity at a time T. So displacement is equal to area of trapezium OCAB, which is equal to 1/2 sum of parallel sides into distance between them, which is equal to 1/2. Parallel sides are OC and AB. Therefore, OC plus AB into distance between these two parallel lines is OB. Therefore, into OB. So, x is equal to 1/2. Value of OC is U. Value of AB, which is final velocity, is V, and OB is T. Therefore, we get x is equal to 1/2 U plus V into T. Again, from equation of motion, T is equal to V minus U by A. Hence, x is equal to 1/2 U plus V into V minus U by A, which is equal to 1/2 2A V square minus U square, or 2AX is equal to V square minus U square, or V square is equal to U square plus 2AX. This is a third equation of motion by graphical method. So we have to give a problem and we have to solve that. A car is moving with a velocity of 60 meters per second. The driver applies brakes to produce uniform acceleration of -3 meters per second square. How far will the car go before it stops? So given parameters are initial velocity, that is u is equal to 60 meters per second. A is given acceleration -3 meters per second square. Here A is negative, means retardation. V is 0. We have to find out value of x. So we know that third equation of motion, v square minus u square is equal to ax. Putting value of given parameters, hence we get x is equal to 600 meter. In this way, we study three equations of motion. First one is v is equal to u plus at. Second is x is equal to ut plus 1/2 at square. And third one is v square minus u square is equal to 2ax, where v is final velocity, u is initial velocity, a is acceleration, t is time taken, and x is displacement. Thank you.